In 2024, hundreds of number enthusiasts gathered in a school hall in London to try and calculate pi to a record number of digits by hand. A project which would require untold hours of doing laborious calculations with nothing but paper and a pen. This was all the fault of ridiculous maths person Matt Parker, and it was not going well.
It is, what are we now? 10 past 7. We're about to start packing up on the end of Friday, day 4 of 6. And I'm still working on a sheet here which goes up to the 100th digit. So that's as far as we've got, and the record is 527. I don't think we're going to do this. We're going to do this. It's the first day. We have a small number of volunteers in, setting up all the sheets, working out the systems, getting it up and going. It's all going so well. We are a few short days and several hundred volunteers away from a record amount of pi by hand.
It had started well enough. On day 1, a core group of 50 or so nerds had gathered to do the preliminary setup calculations. Matt and his team explained how the pi formula was going to work and what initial calculations needed to be done. As the rest of the week would be spent doing long divisions, a lot of times tables had to be generated for the various divisors. These would be referred to extensively in all future calculations. It wasn't exciting work, but everyone was in high spirits.
So far it's very exciting, very busy. I think there's a lot of the initial admin that needs doing that you forget about. But it's nice to get calculating. And now we've started, I'm more hopeful than I was yesterday.
We haven't actually done a calculation like this in 80 years. We don't need to do this calculation. It's just, can we still do it? Do we still have the ability to do these things? I think that's interesting to find out.
Well, I'm cautiously optimistic. I'm fairly confident we'll beat the 2022 record.
Yes, this wasn't the first time Matt and the team had tried to calculate pi by hand. He had made several attempts by himself since 2016, but never getting more than 6 digits correct. In 2020, he had a team of 5 people for one day who managed 5 digits. In 2022, 20 people gathered for 2 days to achieve 11 digits. This time, Matt wasn't messing around. Up to 200 people a day would churn out calculations for 6 solid days. And Matt had a whole new formula.
There is a category of pi equations known as Machin-like formulae, and of the hundreds available, we picked this one. Pi divided by 4 equals, and then you've got the sum of 7 different arctans, each with a coefficient out the front. This means, in theory, we're doing 7 different arctan calculations, which can all be done independently. This is quite parallelizable, so we can keep track of them. We gave them all names, and we went through the rainbow of colors as well. And so the final answer is pi itself. We preemptively multiplied all the coefficients by 4, and all we have to do now is calculate a lot of arctans.
The record to beat was set in the 1870s by British schoolteacher William Shanks. Over several decades, Shanks had calculated 707 digits of pi, but it wasn't until the 1940s that someone found a mistake in the 528th digit, making the current world record of digits of pi computed by hand 527 digits. Matt had even brought a little memento of Shanks' work to help keep him motivated.
Yes, I bought an original 1873 print of Shanks's calculation, which is right there. That's Shanks's pi that they thought was right. Made a mistake, a little embarrassing. We're hoping to fix that. But I thought it'd be nice, just, this is kind of my spiritual predecessor, having it here today. I can't take it actually in where we're doing the calculation because, as well as being a no calculator zone, which makes sense, no calculation devices in there, I probably shouldn't take in 527 correct digits of pi.
As well as the setup, the day 1 crew did start doing a few of the main calculation steps, and the answers which came back were not as correct as they had hoped.
Yeah, we're getting a lot more mistakes than we expected, I'll be honest. I was hoping most of the sheets would match when they come back in again, but the folks over here, you can see the discussion on the checking table. They estimate when they get 2 duplicate sheets back in again, they don't match 75% of the time, which means we're getting a lot of mistakes. Now, we've got systems in place now. Over here, we're gonna send out more copies absolutely 3 each time, which will slow us down a bit, but everyone's having fun. So we'll see how that impacts us when we have a room full of people in on day 2.
Day 2, and 100 new human calculators have joined the core team, bringing the room total up to 150 people. Matt had asked in previous YouTube videos for volunteers, and people had shown up from around the world. The only requirement was the ability to do long division, because division is all you need to compute an arctan.
How do you actually calculate an arctan? Thankfully, there is something called a Taylor series. It's an infinite series of things you have to add and subtract together to give you the value of your arctan. You're adding and subtracting these different fractions with odd powers and odd coefficients underneath. We just need to calculate enough of these. We did it in 2 steps. Because the powers are always the next odd power up, we could first of all work out 1 over x, and then we just divide that by x squared. And then we divide that by x squared. And each time if we divide by x squared, we will get the next 1 over x to the power of some odd number. Once we have those, we then separately divide each one by its appropriate odd value to put the 3, the 5, the 7, the 11, and so on back in. And by following those steps, we have the chain of dividing down that main spine of values, and separately, we're dividing by the odds.
The process for each human calculator was simple. They would join the queue and wait to be issued a calculation which needed to be done from one of the 7 handout desks, 1 desk per arctan. Then they would visit the Pi-brary to borrow the divisor times tables they would need, and then find a seat on the calculation floor and get cracking. Once their calculation sheet was complete, they would hand it back in at the check-in desk, return their times table to the Pi-brary, and start the process again.
We're doing the library section, so our job is to make sure that when people come down to do their divisions, they need their appropriate division table. So if you're dividing by 7, we've got a 7 table right here. And if you're dividing by Pacific squared, which is this absurdly large number, well, you get that table. And they've all been checked and double checked for errors and mistakes. So our job is to make sure people know what to divide by.
I just finished dividing by dot squared, which is the largest number that we have. I completed it and I gave it to check-in, and all I know at this point is it was legible, so it's been accepted.
The error rate in the first days was higher than we expected, and so we have put some stuff in place to catch more errors. We're handing more sheets out at once, so we're originally going to hand out 3 copies of a sheet, and if 2 of them come back correct, we then check them more thoroughly. We were often getting 3 come back incorrect. So for the critical parts, we're now doing 5 copies at once. So rather than 3 come back, then you wait, we send another one out and wait again for that to come back. We're doing all of it at once and hope that means we don't have to sync the time rather than double time for those computations.
But for this to work, the arctan calculation needed to be split into tiny chunks, which could be done individually, one at a time, by a swarm of different humans.
Here's how we actually calculated the arctan in practice. We did it in chunks of 20 digits at a time. So first of all, we calculate the 0th digit to the 20th digit, then we do 20 to 40, 40 to 60, and so on. Down the main 1 divided by x, whatever x is for that arctan spine. We divide all of those by x squared to get the equivalent set of digits for 1 over x cubed, 1 over x to the 5, and so on. The issue is once you've done one chunk of digits, whatever the remainder is has to feed into the next chunk of digits. So each sheet of working out is waiting for the sheet above it to be finished and the sheet before it to be finished. To visualize the odd step, we can turn this wonderful 2D grid into a 3D arrangement where now every single chunk has to be divided by the corresponding odd number to get us our actual series for the arctan. And like before, each of these requires the appropriate spine chunk to be done before it can be done, dividing by the odd number, and there's a carry value which rolls from each chunk to the next chunk after it in the series.
This ridiculous plan, devised by Matt, Katie, Scroggs and the rest of the Pi by Hand Council, meant that there were thousands of pieces of paper that both depended on and fed into other bits of paper. In an attempt to make tracking the pages easier, each sheet was colour-coded. Pink and green for positive and negative spine terms, and yellow and blue for positive and negative odds terms. Surely that would help keep mistakes at bay.
All right, day 3, I feel like We're still making a lot of mistakes. I think we're still over half the sheets have a mistake somewhere on them, which is fine. We have systems in place, but I think we've caught all the errors. It's now definitely got a lot more complex. We've had a lot of logistical challenges today where we've had to invent new tasks, recruit people to do various checks. We've had to buy a lot of clipboards. It turns out moving 10,000 pieces of paper around a room that all rely on one or two other specific bits of paper and have to feed into one or two others is a logistical nightmare. But I'm pretty sure we've found all the ones we lost, all recreated them. We've audited all the gaps. My job now is just to finish this long division very carefully. The slogan we've got now is we want long division, not wrong division. So.
When a complete sheet was given to the check-in desk, they would do some initial checks to make sure it had been filled in correctly, and then pass it on to the next stage. The verification station would wait for 2 duplicates of the same calculation to be handed to them and see if they match. If there was a match, they would pass the paper on. If the incoming answers conflicted, more copies of the same calculation would be sent out to be done again until 2 results were the same. Next, the mod squad would perform modular arithmetic checks on every calculation. These calculations are not able to produce the full answer, but they can verify the answer matches the inputs mod 9, 10 and 11. Now convinced the answer is probably correct, the team moves the pages on to processing and staging, where the sheets sit, waiting for any other outstanding calculations needed before they can progress. Once all the dependent calculations are in, a complete pack of previous results and new blank sheets are given to the human photocopier, who copy the required info onto the new sheets, which are then given to the handout tables, and the cycle continues.
So, behind us we have a table, the verification station, right? They are getting calculations from 2 independent people, and if they match, which we hope they do, they come to us, and we're checking to see if they match by a fluke or if they're actually correct. So we're doing a little mathematical check. We're casting out 9s, which is what we used to do 100 years ago. And if it passes our check, then we can say, yes, this is actually mathematically true and not just randomly happenstance happens to be equal to each other. Unfortunately, everything coming to us is passing our checks here, our casting out 9s check, except for the very dramatic moments yesterday.
Yeah, absolutely. So we had a super dramatic moment where we checked the 9s, cast out the 9s, it's all good, checked the 10s, cast out 10s, it's all good, and then they had 11s, and we checked it again, and we checked it again, and we realised that there was definitely an error, and this was quite early in the calculation. So what happened is 2 people had made exactly the same mathematical arithmetic error that our casting 11s checked, otherwise it would have all been passed into the sums and everything would have gone very well.
Yeah, everything from that point on would have been wrong.
The next 3.5 days of maths.
And most of the stuff we're getting is passing, which is a lovely sanity check. Because without this, we wouldn't know that things are actually working. So we can tell you things are actually working and dramatically cut out a mistake.
That's it. It was very exciting. High fives all round.
The record, I think, is something that we've all kind of got in mind as it would be nice to be able to break that record. And I guess comparing it to what Shanks did was literally just sit on his own and work on it. And that's fine if you've got, 30 years. But given that we've got a week, we kind of need to compress that into a much smaller time scale, which is going to mean a lot more people are involved. It's a lot more, I think it sort of scales badly. Right, so the more people you have involved, the more time you need to spend briefing them, the more logistics you need around all of that. So scaling up doesn't necessarily just mean, this much time times this many people or whatever. But I think from what we did last time, we've kind of figured out maybe how to scale it up. And we did all of the maths on like how many more sheets of paper we need, how many terms are we going to need, depending on which formula we use, how is that going to change? But even then, there's going to be things that you don't anticipate. So like delays in terms of, you get little backlogs, you get little kind of bottlenecks where one particular calculation gets done by a few people and they come back and they don't match, so you have to resend them out, or you have to do them again, or you have to find where the error is. That then slows down not just that one, but all of the ones after that. So that kind of thing makes it take longer than you're expecting it to, right? You can sit at home and do some long division, but you can't calculate pi on your own. And I think the fact that people will come here to get involved is partly because they want to, contribute to that, and also to be able to say, actually, that was me, I was part of that thing. And I guess wherever we get to, we've all done something we'd never otherwise have normally done, and it's a fun time, it's a good excuse to come. And also these people are great. Like we've met so many new, like all the volunteers, new friends, new cool maths people that we didn't know before, and I think that's really nice.
Also in the room was the current world record holder for computing pi by any means, Emma.
I happen to work for a cloud service provider, and I had access to computing resources I could use. And my team was celebrating Pi Day every year. So when we were planning for 2019 Pi Day, I realized maybe we have enough computing resources to break the world record. I see these as two separate categories: humans, like human processors, and as a software engineer or someone in computer science, I see this whole process as someone said microarchitecture, but yeah, it's a processor, like parallel processing system. So you have a large number of computers, like human calculators, doing the long divisions, and then we have, so in the actual computer, you have, when you look at the CPU, you have actual processing units in a tiny portion of the overall processor, and then the rest is key to keep these processors fed. So you break down the instructions, reorder them, and then retire. So dispatch them out of order, and then reorder them. So everything is in package processor, and I find this process really similar to that that analogy. And I enjoy kind of watching these kind of mechanism and system processing running smoothly.
Day 4, and things are only getting more complicated. The collapsing station has now kicked into action. They are taking the final results coming in for each arctan and start adding up all of the terms together. It's slow, methodical work. Meanwhile, at the far end of the room, a new department has sprung into existence, the Central Intelligence Archive. Originally envisioned as a cardboard box where used papers could be dumped, the archive now had a full staff of people maintaining a highly organised record of the calculation thus far and running extensive double checks and audits on the pages. They have also trained up several progress enforcement officers, one for each arctan, who roam the hall with clipboards, making sure all the pieces of paper are accounted for and are moving through the system. But despite all this admin, the papers are not moving fast enough.
Day 4, and we're excited that we got to 60 digits, which is, good. 60 very thorough, very carefully calculated digits, but it's not 600, is it, for the record? So we've got a room full of 200 people working very hard to maybe get to 100 by the end of day 4. So yeah, I've just got to keep dividing.
With ever-increasing complexity and still a high error rate, Matt realises the world record has slipped out of his grasp.
Matthew, why aren't you doing your long division?
Shanks? Is it you?
Well, yes. Even though there are no confirmed pictures of me, I think we can probably agree this is bang on the money.
Yeah, no, good point. Look, can I call you William? Will? Billy?
No, Mr. Shanks is fine.
Okay. Mr. Shanks.
Emphasis on the Mr.
Mr. Shanks. I cannot believe, having been through all this, that by yourself you were able to do 707 digits with a single mistake.
Well, I've had years, decades, toiling away on my own. And I'm better at maths than you.
Okay, valid point, but I've got, over 100 people, most of which are better at maths than me, and we're doing this for a week and we are going to struggle to get to 100.
In my day, I had to work alone. It took me years by myself. And when I was finished and dead, no one even checked for over 70 years. But you, look at your vast group. You put a call out on this YouTube, and hundreds of nerds descended from around the globe. And sometimes the real irrationality is the friends you made along the way.
That's transcendental of you.
Is everyone having fun? And a good time?
I think everyone is.
Well, then they're not dividing hard enough. And you, get back to work.
Yes, sir.
That's Mr.
Mr. Shanks, sir.
Good boy.
And get back to work Matt did. He divided harder and more carefully than ever before, doing his part as a tiny cog in a massive calculation machine. Day 5, and no one seems to be giving the record a second thought. The room full of 200 number fans continued working away as fast but as carefully as they could. Everyone now fully in the swing of doing something which hasn't been attempted for over a century. Everyone was curious to know just how far through the digits of pi they would be able to reach.
I think there's a lot of people here who have done maths in the past and kind of just miss doing the simple stuff. I say simple, long dividing by 150 billion isn't exactly simple. It's just nice to remind yourself of, I guess, where your roots are in a way.
Yes, we've only got a couple hours left before we're done on kind of the last day. Tomorrow we have to do the final calculation, and we've realized we're not going to get past 140. And what's amazing is everyone's having a great time and working together, and no one's sad that we're not. I mean, obviously it would be great to have gotten more digits, but everyone is so excited at the prospect of 140. Just like, that's a thing we might be able to achieve is great. And we're over 100 digits we're confident about. And I mean, there's 200 people who are, despite everything that's happened to us, are dividing, but they're not divided.
With 1 day remaining, it became very clear that if the team wanted to hit the next digit milestone, they would need to try something different. So the core team planned out the Hail Mary protocol. The new plan was simple. The human machine, which had evolved over the week, would continue as is for all sheets up to digit 120. Anything above 140 was cancelled.
No, so the checking is still happening, but the checking is happening concurrently to the next division happening, so that we can hopefully go faster and try and get down these last few turns so we get
So we kick off the next division before we've checked the previous one. As long as we know we've got 2 copies that are the same, because that's a kind of basic level check, we'll start the next one, and then the more thorough check happens sort of in parallel with that. So we end up, if there is an error, we can kind of chase it back and go, stop, come back and do that one again. But it means that we can just jump straight to the next one. So we've been able to do the remaining chunks for the whole of the next, I guess, set of digits in the space of 3 hours. So it's been fast,
It's been faster than yesterday, but we also have made no progress on the next 20, so there's no point now starting the next 20 because
there's
way
even more
behind.
things to do on those because it's longer. Yeah, I think we're sort of secretly in our heads wondering if this is actually a better method to use for next time or what the problems with it are. And we're sort of, I guess we'll continue thinking about that until we try this again. If we try this again. When we try this again. When we try this again.
The final steps were adjudicated by ardent Tau fan and someone who would find it very funny if Matt's calculation had a mistake, Steve Mould.
If there's any uncertainty about how
how legit this calculation has been. We have an independent observer who's just here to check everything as we're wrapping up in the right place.
Yeah,
So-
and I haven't seen any calculators come out. It's all been above board. Everything seems to have been done by hand. I've checked some of the numbers as well. You know, I love half town day. I don't know why we do it on the half, but that's just you've got a special word for it, haven't you?
I follow Steve around to make sure he doesn't try and multiply anything by 2 when I'm not looking.
The collapsing station is carefully summing up all the final positive and negative terms into 2 grand totals. These are dutifully copied out onto 2 large pieces of paper for the final grand subtraction. Digit by digit, Matt subtracts one number from the other with hundreds of eyes watching out for even the smallest mistake. Now, all that is left to do is to verify the final answer and see how many digits of pi are correct. If they get fewer than the previous attempt's 11 digits, this is going to be really embarrassing.
You got pi?
Got pi.
So, we're going to do it like we did before. I'm going to read it out. Katie's going to say yes or yep or uh-huh. And Sophie's doing the over-the-shoulder checking. I think I'll just point. And when we get to the bit that's wrong, I'll draw a sad face. Job done. Okay.
To be clear, Sophie's also going to check that we don't walk backwards into anything.
Oh, that's true. That's a very important task.
Yeah.
Halfway, we'll swap, and I'll go back, and you can be trying. Okay, 3.
Yeah. So it's on a different line.
Oh, that's a good point. That's a good point. The 3 is like, yeah.
I was like, no, I was expecting 1. No.
3.1.
Yep.
4.
Yep.
1.
Yep.
5.
Yep.
9.
Yep.
2.
Yep.
6.
Yep.
5.
Yep.
3.
Yep.
5.
Yep.
8.
Yep.
9.
Yep.
I don't think anyone is surprised so far. 7.
Yep.
9.
Yep.
3.
Yep.
2.
Yep.
3.
Yep.
8.
Yep.
4.
Yep.
6.
Yep.
We're ahead of last time. Okay. How can such a chaotic flurry of calculations give such a predictable result? Like maths. 2.
Yep.
6.
Yep.
4.
Yep.
3.
Yep.
3.
Yep.
8.
Yep.
3.
Yep.
2.
Yep.
7.
Yep.
9.
Yep.
5.
Yep.
0.
Yes.
2.
Yep.
8.
8. Yep.
8.
Yep.
4.
Yep.
1.
Yep.
9.
Yep.
7.
Yep.
1.
Yep.
Genuinely surprised. Okay,
Yeah.
that's 40 if you want to swing around over there.
I'll try not to
over
say
here.
numbers. That's really confusing.
What's that?
I just instinctively said 8.
Yeah, it's
But I
fine. Mix it up. Do a Scroggs, as we call it.
I'm not going to say any numbers. It's not happening.
Okay. Now, we've just read 971.
Yes.
Okay. 6.
Yes.
9.
Yep.
3.
Yep.
9.
Yep.
9.
Yep.
3.
Yep.
7.
Yep.
5.
Yep.
1.
Yep.
0.
Yes.
5.
Yep.
8.
Yep.
2.
Yep.
0.
Yep.
9.
Yep.
7.
Yep.
4.
Yep.
9.
Yep.
4.
Yeah.
4.
Yeah.
5.
Yep.
9.
Yep.
2.
Yep.
3.
Yep.
0.
Yep.
7.
Yep.
8.
Yeah.
1.
Yep.
6.
Yep.
4.
Yep.
0.
Yep.
6.
Yep.
2.
Yep.
8.
Yep.
6.
Yes.
2.
Yep.
0.
Yes.
8.
Yep.
9.
Yep.
9.
Yes.
Okay. I've got to stop sounding so surprised every digit. I feel like...
I'm going to get increasingly surprised. At some point, instead of yes, I'll just say somehow.
What? Yeah. 8.
Yes.
6.
Yep.
2.
Yep.
8.
Yep.
0.
Yep.
3.
Yep.
4.
Yep.
8.
Yep.
2.
Yep.
5.
Yep.
3.
Yep.
4.
Yep.
2.
Yep.
1.
Yep.
1.
Yep.
7.
Yes.
0.
Yep.
6.
Yep.
7.
Yep.
9.
Yep.
8.
Yep.
2.
Yep.
1.
Yep.
4.
Yep.
8.
Yep.
0.
Yep.
8.
Yep.
6.
Yep.
5.
Yep.
1.
Yep.
3.
Yep.
2.
Yep.
Awfully drawn 8.
Yep. It's all right on here.
Okay. Just when I think my respect for Shanks couldn't get any higher. 2.
Yes.
3.
Yes.
0.
Yep.
What?
Yep.
Did you say 0 and I heard no?
I said yeah.
Oh, said yes.
You said 0.
I think I'm just slipping into a dreamlike trance.
Yeah. It's good that we got the 3 tiredest people in the room to do this.
This is really good. So, just to recap, we just had 2, 3, 0.
Yes.
Now, we are coming up on 120 digits, so we are safely into the hundreds. We'll see how far we can get now. So let's get to 120. We just had 2, 3, 0. It then goes 6.
Yes.
6.
Yes.
4.
Yep.
7.
Yep.
Okay. Final. Now, I mean, what's nice?
Bit of a miracle.
I mean, what's nice is if there was a mistake, like we were so confident we'd checked so much, I don't know how we'd reverse, I was worried there'd be some systematic or, phantom error, but we're okay. Now we hit the uncertain zone. We're semi-confident with the first 15, so let's check those. 0.
Yes.
9.
Yep.
3.
Yep.
8.
Yep.
4.
Yep.
4.
Yep.
6.
Yep.
0.
Yep.
9.
Yep.
5.
Yep.
5.
Yep.
0.
Yep.
5.
Yep.
8.
Yep.
2.
Yes.
We can't applaud every digit. So.
We need moral support.
Yeah. I will fall over.
It's not a race. Okay. They can't see them. I'm blocking them. Okay, here we go. We just did 5, 8, 2.
Yeah.
Then there's another 2.
Yes.
Yes.
3.
Yes.
Yeah.
1.
Yep.
Yeah.
No! Okay. I mean, this is a lucky dip. 7?
Yes. No.
Ah, that's it. That's pretty good. I'm as surprised as anyone. That's phenomenal.
That's it. Huge thanks to the Pi Day Organising Committee of Alex, Eliane, Ben, Christian, Deanna, James, Katie, Max, Nicole, Scruggs and Sophie who've been working on this for the past 2 years. And thanks to all the volunteers who stepped up and did all sorts of phenomenal work above and beyond the call of duty that made this possible. More names than I can possibly thank. They're all scrolling by here. And if you want to be involved in something like or maybe this in the future, there's a link in the description below. You can sign up and I'll let you know when I'm next planning something this ridiculous. And this was funded by my Kickstarter funders who funded my Humble Pie stand-up special filming. I said I'd use the surplus funding on something else, and that's what paid for this ridiculous Pi Day calculation. If you want to help fund other videos and projects, of course, you can go to my Patreon, get involved. The more support I get, the more ridiculous maths occurs in the world. Thank you so much, everyone.
I'm feeling great. We got so many digits. I really can't believe that. It was really fun. And now I gotta go back and finish my PhD. I took a week off for this.
I came here for pie, and all I got was sandwiches.
Yeah, it was like Comic-Con, just for mathematicians.
Pretty emotional. It feels like the end of a pretty incredible couple of days. Pretty sad it's over, but I think we did a pretty good job.
Great, I really enjoyed the bit with the maths. I should probably get some sunlight and some sleep.
I'm looking forward to calculating more things.
I had such a good week. I was here since Wednesday, and honestly, everyone here is absolutely lovely. And we calculated a number.
I think the mathematical community will be shaken by our new discovery that pi just ends abruptly at 139 digits.
This has been some of the most incredible few days of my life. To be surrounded by so many people, all passionate about the same thing, has been an incredible experience.
Say what you want, but that surprise ending came out of nowhere.
Incredible results. I literally cannot believe it. This was very worth the trip.
Yeah, well, I mean, after it all, Matt was going on about how once the only remainder that he has left is the good memories, we'll do it again. But I can't help but think, if that's the remainder, where's the quotient?
Yeah, well, I mean, I don't like giving things a scale from 0 to 5, but I give this one probably a 3.1415.
Honestly, it just felt kind of nerdy.